Ma'am.
Hello.
Ma'am.
Hello. Shall I start the class now? I am now two more have to join. Yes, tell me.
Ma'am, actually,
Sanjay?
today we've assigned, given as an assignment, assignment 3.
What is given in the message?
No, ma'am, you have given us an assignment, right? In the app.
Yeah. Yeah.
Ma'am, if you open that, there's nothing, ma'am. We've not got the PDF assignment, ma'am.
You did not get any PDF assignment yet?
No, ma'am. It's they've given us a heading like assignment 3 practice exercise 1, ma'am.
But
there is not a PDF or something like that.
Okay. I will message them and ask them what is the problem. Okay, I've messaged them. If there is a problem, then they will rectify it. Yes. Okay, children. So I will begin now. Hariharan, Vaishnavi.
Yes, ma'am.
So now some more people have to join. They haven't joined. I don't know whether they are joining. Hari Raghav has also come. And now Gopal and Madhavan is there. Madhavan has to still join. Okay, so today we are going to start with this new topic on solutions. Okay, so first tell me what are, so you have already learned about different types of solutions. What is some thought that comes to your mind when you talk about solutions? Can
you tell me? It is a mixture of pure substances.
Tell me, Vaishnavi.
Ma'am, mixture of pure substances.
Mixture of pure substances. Okay. Then Sanjay, anything that you know about solutions?
Ma'am, basically a mixture of something, ma'am.
A mixture of something, right? Okay. What about you, Hariharan?
It's a mixture of solvent and solute, ma'am.
Okay. So it is, all of you agree that it is a mixture, right? That is what everybody agrees, mixture. And you also now agree that it is a, now Hariharan has given some more information. It is a mixture of a solute and a solvent, right? When do you call, when you mix two components, when does it, what is the difference between a mixture and a compound? How is mixture different from a compound? Vaishnavi? When you make a compound also, you mix two substances together. What is the difference between a mixture and a compound? Any difference? Supposing I mix hydrogen and oxygen.
Ma'am, maybe solution is a mixture of? Ma'am, mixture of compounds is solutions.
Mixture of components is solution. So supposing I mix hydrogen and oxygen, is it a mixture or is it a solution? No, is it a mixture or is it a compound?
Ma'am, compound.
So is there a difference between a mixture and a compound? If I mix nitrogen and oxygen, is it a mixture or is it a compound?
Compound.
Why? Nitrogen and oxygen in the air, they are present in the air, no? Nitrogen and oxygen, do they form a compound? Normally they don't form a compound, right? Now, supposing I take salt and water, Is it a mixture or is it a compound?
Mixture.
It is a mixture. So basically, see, what you have to see is that when it is a mixture, there are a few important things. There is always a solute and a solvent. The important thing is that the components don't react chemically. Components do not react chemically. Okay. If I take hydrogen and oxygen simply, then they don't react chemically. But if I mix hydrogen and oxygen under special condition, you put an electric spark, then they immediately react and form water. Nitrogen and oxygen don't combine and form oxides of nitrogen. When do they form oxides of nitrogen? During rain, lightning, and thunder in the upper atmosphere, they combine. Normally, nitrogen and oxygen don't combine. So components of mixture do not react chemically. Okay, so if it is a mixture, like if I mix salt in water, right? If I mix salt in water, then salt and I get a solution of salt and water. So if I have a salt solution, right? In the salt solution, what do I have? I have a solute, which is salt, and I have water, which is a solvent, right? And salt and water do not react, right? Supposing I take water and I add sodium to it, right? If I add water and sodium to it, then it becomes sodium reacts with water, right? Then it is not a mixture of sodium and water anymore. It becomes a solution of actually hydrogen is given out and sodium hydroxide is formed, right? So this is not a true mixture. A true mixture is one like salt and water where the components do not react. All right, so that is the one condition. Then the other condition is that they are not chemically combined. The components are not chemically combined. And the other important thing of a solution is that it is, see, there are many mixtures. If I mix sand and salt also, it is a mixture. But it is mostly one important property which you always consider for mixture is that they are heterogeneous, whereas compounds are homogeneous. But solutions are, it is homogeneous. Solutions are homogeneous mixtures. Very important is they are homogeneous mixtures. Homogeneous mixtures. Solutions are homogeneous mixtures. Okay. So it is important to understand that they are homogeneous mixtures, genius mixtures. Okay. So solutions are made up of two components. There is at least one solute and a solvent. You can have more than one solute, and it is a homogeneous mixture. Mixtures are always homogeneous. Now, what is a solute and a solvent? Let us think about that. Okay, so if we think of solute and solvent, supposing I have, before that, different types of solutions, let us think. We talked about a solution of solid and liquid. Normally, we think of solutions of solids and liquids. So that you already gave an example, salt solution. Okay, salt solution is there, sugar solution is there. Anything which is soluble in water will make a solution with aqueous solution of water. So solids and liquids, it need not be, the solvent need not be always water. It can be sometimes some other, it could be benzene, naphthalene dissolving in benzene, that will also form a solution. Now, supposing I have a solid and a solid. The solute and solvent both are solids. Can I have a mixture of two solids? That is my question. Can I have a, solution of two solids? Can I have a solution of two solids? Tell me. Anyone?
Solid gel, ma'am.
That is also possible. A very good example of solid solutions are alloys. All the alloys, like copper and zinc form brass. You have magnesium, which is used for aircrafts, duralumin. So these are all different types of alloys. So solid and solid solutions are also there, like alloys. You can have gas and liquid solutions also. Do you know any gas and liquid solution? Gas dissolved in water? Any solution like that, do you know?
Aerosol, ma'am.
And soda.
Soda, yes, very good. Soda is a very good example where carbon dioxide is dissolved in water. Okay, so that is a good example of solid-solid solution, gas in liquid solution. And you can have gas and gas also. That is air. Okay, all these are homogeneous mixtures. All these are mixtures, and they are homogeneous mixtures where the components do not combine. When copper and zinc form an alloy, the components don't combine, but it still forms a homogeneous mixture. When carbon dioxide dissolves in water, it forms soda. It is a homogeneous mixture. Okay. Now you could also have liquid and liquid, liquid plus liquid. If it is liquid plus liquid, what is the example? Can you tell me anything? Alcohol and water, isn't it? Alcohol and water also is a solution, isn't it? So alcohol plus water. That is an example of a homogeneous solution of two liquids, homogeneous solution of two liquids. So like that, you could have different types of examples. Now, supposing I have, just to clarify your concept of solute and solvent, supposing I have 20% ethanol and 80% water in the solution. I have 20% ethanol and 80% water in the solution. What is the solute and what is the solvent? Which one is a solute and which one is a solvent?
Ethanol is solute and water is solvent.
Ethanol is the solute and water is the solvent. Okay, why did you decide that, Vaishnavi?
Ma'am, solvent is the substance which is present in large amount and dissolves the lesser amount of.
Correct. So if I change the composition and I make 20% water and 80% solvent, water and 80% ethanol, then ethanol becomes the solvent, right? And water becomes the solute. Okay, so the solvent and solute. So why I am saying this is that when we take salt solution, then we always in our lower classes, we learned that, the salt is a solute and water is a solvent. So we always think of water as a solvent, but it is not always true. If water, in this case, second case, if water is only 20% and ethanol is 80%, then water is a solute and ethanol becomes the solvent. Okay, so the one which is lesser quantity is a solute. The one in the mixture which is larger quantity can be defined as a solvent. Okay, so that is about. Now we need to learn different ways of expressing a concentration of the solution. Okay, so concentration of solutions. Okay, different ways of expression of concentration of solutions. Now, supposing normally when we are talking of solutions, we are assuming that your solute is a solid and your solvent is a liquid. That is a type of solutions for which we will do all the examples and practice. We will do also liquid solutions, gas liquid solutions, but mainly we'll talk about solid and liquid solutions. So there are different ways of expressing, right? So supposing very simple way of expressing the concentration of the solution is, supposing I take 10 grams of NaCl and I dissolve it in water. right? I dissolve it in water. So dissolved in 100 ml of water. Because water is a liquid, I might decide to choose the unit as ml, and 100 grams of sodium chloride. So what will be the concentration? Now it will be very difficult to decide the concentration if I don't know the proper way of expressing concentration, because I could say 10 grams per ml, 10 grams per 100 ml. Okay. Now 10 grams of per 100 ml of water. Now this is not a standardized way of expression of concentration of a solution. So there are some standard ways of expression. We will learn that. We can't just simply say the weight and the volume and then decide the concentration. We have some standard ways. So the first way of expression here So the first way of expression of concentration, this is the first method. It is called mass percent. Mass percent, sometimes it is written as weight by weight. When we say mass percent, it means weight of the solute divided by the weight of the solution. Weight of solute and weight of solution, both it is mass. The other way is, other important thing is that in most cases, we talk about, we express the concentration of our, just one minute, I'll have to close the door, there's a lot of noise outside. Okay, so mass percent is weight by weight. That means weight of the solute, mass of the solute divided by the mass of the solution. So what will be the mass percent? Weight by weight percentage is equal to mass of solute divided by mass of solution. Always we take mass of solution in the denominator. It's not that sometimes we take solvent, sometimes we don't take, mostly, except one case, we will take always the mass of the solution. Always we'll talk about the solution in the denominator. So mass of the solute divided by the mass of the solution into 100. Okay, that is our formula number 1. Okay, so what is weight by weight percent? Mass of the solute divided by the mass of the solution. So let us do one question here. Calculate the mass percent of benzene and carbon tetrachloride. Where is my complete question? If 22 grams of benzene is dissolved in 122 grams of carbon tetrachloride. Okay, how will we do this question? So always when you have the question, you should write down the data first. What is the data that we have? Data is, we know the solution is between benzene and carbon tetrachloride. So what is the mass of benzene? Mass of benzene is what? It is 22 grams, right? Mass of carbon tetrachloride, CCl4, is 122 grams, right? By seeing this, what do you understand? This is the solute and this is the solvent. This is the solute and this is the solvent, right? So first of all, what do you need? Mass of the solute, that is already there. You need the mass of the solution. So what is the mass of the solution? Mass of the solution is
22.
So that is 144 grams. All right, 144 grams. So what will be weight by weight percentage? Mass percentage will be equal to 22 divided by 144 into 100. What will that be? You are not allowed a calculator in the exam, so you should try to do it without a calculator. So you can divide by 12, I think, 11. So 11 here 2, and this is no, 11, I can't divide by 11. Sorry.
Eleven by 72.
Yeah, it will be 11 by 72. Yes.
This one, 11 by 72 into 100.
Yeah, 11 by 72 into 100. Okay, so it will be 22 by 144. So it will be 11 by 72 into 100. Okay, now, huh?
15% approx.
Okay, 15% approximately. Right? Now here, I would suggest that in the exam, if you have no time, then you should leave the fraction at the end, right? Because the final answer, if you don't write, then you lose only half mark. But if you don't write, the marks are always distributed in how you write the data, whether you have taken the correct formula, and at the end, whether you are writing the correct answer. So if your answer is wrong also, you lose very few marks. So you can, if the time is short, you can try to leave it as a fraction. Normally in the exam, the questions are asked in such a way that you have, it will all cancel out. So if I had made this question, I would have written 134 here. So if I write 134, it will cancel with 11 and you will quickly get the answer. Now the next one is volume percent. Volume percent is volume by volume. What does it mean? You take the volume of, this is normally for mixtures which are liquid mixture. So volume percent we take the volume of the solute as well as the volume of the solution. So this will be my volume percent is equal to volume of solute divided by volume of solution into 100. Volume of solute divided by volume of solution into 100. So if I take a question for that, so if I say that it is 10% solution of ethanol. Okay, what does it mean? 10% solution of ethanol, what does it mean? So 10% solution of ethanol means you have 10 ml of ethanol in 100 ml of solution, right? So what is the volume of water here? What will be the volume of water? The question is, you have 90 ml. Did you understand? 10 ml of ethanol. What does 10% solution of ethanol mean? First of all, 10% means 10 ml of ethanol in 90 ml of solution. So if in 100 ml, 10 ml is ethanol, then 90 ml is what? Water. Okay, so these are very, very simple questions which you do in class 10 also. So it is easy. Now we'll come to the next one, which is mass by volume percent. Mass by volume percent, mass by volume percent. So what is mass by volume percent? Here the mass is of the solute. So mass of solute, we are taking actual mass of solute divided by volume of solution into 100. Mass of solute divided by volume of solution into 100. Okay, so whatever, there can be some easy question for this also, that you have, for supposing I have 10 grams of NaCl dissolved in 200 ml of solution. Okay, the volume of the solution is 200 ml and I have dissolved 10 grams. What will be mass by volume percentage? It will be 10 divided by 200 into
10 by 200 and 200.
Yeah. So that will be
200.
That will be 5%. Okay. Now we'll take one more situation, one more condition. This is expressing concentration in parts per million. Okay. So how do you express concentration in parts per million? That is, number of, whatever the component, the mass of say, for example, I take mass of solute upon total mass of solution. Now, instead of per 100, it is per million. So what is it? Into 10 raised to 6. So if I, like for example, when you find the amount, try to find the amount of oxygen dissolved in water, then you take the mass of the solute in the divided by mass of solution, and whatever unit you take, multiply that by 10 raised to 6, that becomes parts per million. So when the amount of solute is very small, very, very small compared to the amount of solution, then we express the concentration in parts per million. That is also known as ppm. Whenever you have this, we don't have, I'm just telling you this because this is also a method of expressing concentration. The impurity in water is always measured in ppm. When you use your RO plant at home for purification of water, the person who comes to check the RO, he always checks the ppm of water, right? So the ppm of water should be, within 30, 0 to 30 ppm, that means the water is potable. That means you can use that water. But if the water has high ppm, like it has ppm above 100, that means the impurity in water is more than 100 ppm, parts per million, then that water is not potable. So when the impurity is very less compared to the amount of water that you are talking about, then you express the concentration in parts per million. Anyway, this part does not come for any numericals. This is just for your general knowledge. So say, for example, if I say that there is 5.8, like seawater is, like for example, in seawater, right? The concentration of oxygen is 6.6 into 6.0 into 10 raised to minus 3 grams per kilo in 1 liter of seawater. In 1 liter. So seawater, it contains 6.0 into 10 raised to minus 3 grams in 1 liter. 3 grams of salt, you can say, salt in 1 liter. Okay. So here you can see the mass of solute is 6.0 into 10 raised to minus 3. And here the you can say the volume of the mass of the solution. If you assume that the density of water is 1 gram per liter, then you can say this is 100,000 grams. Then the concentration becomes very less. It will become 6 into 10 raised to minus 5. So you express the concentration in parts per million. So you multiply it by 10 raised to 6. So ppm will come to about 6.0 ppm, 6.0 parts per million. Did you understand what I'm trying to do?
Ma'am, can you say how 1000 came again?
1000 I said because it is 1 liter of water, 1 liter water, right? So in seawater, 6.0 into 10 raised to minus 3 grams of salt is present in 1 liter of seawater. All right. Now I have assumed, I've made an assumption. What is the assumption? Assumption is that density of water is equal to 1 gram per ml, right? So 1000 ml is 1 liter is how much? 1000 ml. So 1000 ml is equal to 1000 grams.
Okay, ma'am.
Okay, so if I want to make it mass by mass and talk about ppm, then I can convert it into the mass of the solvent, mass of the solution. Okay, now so that ppm is just generally, not many questions are asked, but mole fraction is a very important one. Let us now understand what is a mole fraction. Okay, so supposing I have a solution. See, mole fraction is equal to the number of moles of solute divided by number of moles of solute plus the number of moles of solvent, number of moles of solvent. Or you can say divided by total number of moles in the solution. So mole fraction of the solute, right, is equal to number of moles of solute divided by total number moles of solute plus the number of moles of solvent, right? Now this I can copy to another page, Control X. Right, so here let me explain. Now supposing the number of moles of solute is equal to N1 and number of moles of solvent is equal to N2. So what is the mole fraction of solute? Of solute will be equal to what? It will be equal to N1 upon N1 plus N2. Okay. If there are more than one solutes, then all the components which are present in the solution, the total number of components there should be there in the denominator. Okay. So let us do a few examples to understand this. Supposing I have, say, 46 grams of ethanol I have a mixture, 46 grams of ethanol plus 54 grams of water, right? I want you to find out the mole fraction of ethanol. What is the mole fraction of ethanol? (46 grams of ethanol and 54 grams of water. What will we do now? I'll write here again, 46 grams.
0.16.
0.46. No, what is the mistake that you are making? Tell me. Now, how do you find number of moles of ethanol? Number of moles of ethanol. Do you know?
Given mass by molar mass.
Given mass by molar mass. So what is the given mass? 46. What is the molar mass of ethanol? Speak out quickly. C2H5OH I have written there. So what is it? 24 plus 6 plus 16, right? So that is also 46. So 46 divided by 46, how many moles? 1 mole, right? What is the number of moles of water?
Yes.
What is the number of moles of water? Tell me. Similarly, mass by molar mass. Mass is 54. Mass is 54 divided by 18. Isn't it? So what will that be? 3. 54 divided by 8. Yes. 54 divided by 18. It is 3 moles. So what is the mole fraction now? Mole fraction of ethanol. C2H5 is equal to OH is number of moles of ethanol, which is 1 divided by number of moles of ethanol plus the number of moles of water. So it will be equal to 1 by 4 or 0.25, isn't it? Now, same way I can find the number of moles of water, mole fraction of water. Mole fraction of water will be what? Mole fraction of water will be equal to moles of water, 3, divided by total number of moles, that is 3 plus 1. So that is equal to 3 by 4, isn't it? Is equal to 0.75. Did you understand? There is no unit for mole fraction. It is only the fraction. Mole fraction means it is a fraction. So of the total number of components present, what is a fraction of one component? That is the mole fraction. Now let us do one question from your book. Calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. Okay, mole fraction of benzene present in a solution containing 30% by mass. So what does it mean? 30% by mass is benzene. So of benzene. Okay, so what does it mean? Mass of benzene is equal to 30 grams. What is the mass of the solution? Mass of solution of 30% it is, no? So mass of solution of benzene and benzene plus CCl4, carbon tetrachloride is CCl4, is equal to 100 grams. So mass of carbon tetrachloride is how much? That is equal to 100 minus 30, that is 70 grams. So you know that there is a solution in which 30 grams is benzene because it is 30% by mass and 70 grams is carbon tetrachloride. Now can we find the mole fraction of benzene? How can we do that? First, find the number of moles. Moles of benzene. Benzene is C6H6, right? So 30 divided by C6H6, 72 plus 6, 78. 30 divided by 78. Okay. So if you want to leave it as a fraction, you can leave it, or you can clear the fraction now itself. So it is 0.385. So it is 0.385. All right. Then number of moles of CCl4, carbon tetrachloride. That is 70 divided by carbon is 12, and chlorine is 35.5, 71 plus 71, 142. So it is 154. All right. So divided by 154. So what do you get? 70 divided by 154, approximately 0.45. 0.45. So this many moles, and this is 0.45 moles. Okay, so what will be the mole fraction? Mole fraction will be equal to 0.385 divided by 0.45. What will you get?
Ma'am, it is 0.385 by 0.45 plus 0.385.
Yeah. Mole fraction will be, I was just going to write that. It has just, this is preventing me to write here. Let me see if I can. I'll have to take it to the next page. So mole fraction will be equal to, what is it? 0.385, 0.385, and tell me what is it for the other one? 0.45. So it will be 0.385 plus 0.45. So what will you get? 385 plus 0.45. So it is 538. So interesting. 0.385 divided by 0.835. So 0.385 divided by 0.835. Okay. So the mole fraction is 0.46. Did you get this?
Ma'am, I got 0.4.
0.
Ma'am, I stopped at 0.4.
Okay, 0.4. Doesn't matter. 0. Okay, mole fraction is this one. Now, this is mole fraction of what? This is mole fraction of benzene. Now, if I want to find mole fraction of carbon tetrachloride, how will I do? I will have to write the same thing, but this time 0.45 divided by 0.385. I can also do another thing. You will always find that the sum of mole fractions is always equal to 1. So mole fraction of carbon tetrachloride, if I find without any calculation, you will realize it should come to around this 4 and here 0.54. Mole fraction of carbon tetrachloride will come to about 0.54 if you do the calculation, because the sum of these two, sum of mole fractions is always equal to 1. So mole fraction of carbon tetrachloride is 1 minus mole fraction of benzene. So I can also write 1 minus 0.46, that is equal to 0.54. So a faster way of doing is, if you know the mole fraction of one component, you can find the mole fraction of the other by subtracting it from 100. Okay, so that is about mole fraction. So if you have two components in the mixture, the concentration of one component can be expressed in the terms of mole fraction. But remember, you have to convert the mass of the component into its moles. It should always be in terms of moles. That's why we call it mole fraction. Now let us see the most important expression which you have learned in class 10, isn't it? Molarity, right? Expression or expressing concentration in terms of molarity. Who will tell me what is molarity? Anyone? Hari Raghav will tell me. Now today you are quiet. Tell me, what is molarity, if you know?
Molarity is basically in we can do it liters. Given mass by molar mass divided by solution in liters.
Very good. Very good. So molarity is expressing concentration in terms of moles. So it is basically, it is moles divided by volume of solution, but that should be in liters, volume of solution in liters. Moles divided by volume of solution in liters. And what is moles? You have already told me. Moles is mass of solute, moles of solute divided by volume of solution in liters. So what is moles? If the mass of solute is W1 grams and molar mass of solute is M1, okay, and volume of solution is VML. Just 1 minute. I'll just be back in a minute. I'm so sorry. So volume of the solution is volume of the solution is VML, not in liters, but VML. So what will be the molarity? Molarity we express in capital M. Okay. So molar mass of the solute is M1. And so what will be the molarity? So first we'll find, for finding the molarity, first what will we do? We will convert the mass of the solute into the moles. So moles of solute is how much? Moles of solute is equal to W1 by M1. Okay. And what is the volume of solution in liters? Will be V divided by 1000. Because this is in ml, so divided by 1000. So what is molarity equal to? Molarity will be equal to W1 by M1 divided by V by 1000. So I can write molarity is equal to W1 into 1000 divided by M1 into V. Okay, this is our very important formula number 1. Okay, so let us do a question. So you have to calculate the molarity now. Calculate the molarity. Calculate the molarity of a solution. Containing 5 grams of NaOH in 450 ml of solution. Now let me see who does it first. Molarity is, before you do the question, let me tell you the unit of molarity. Unit is very important. Unit will be moles per liter or moles per decimeter cube, anything. Okay, now do it quickly. Sodium is 23, oxygen is 16, hydrogen is 1. Anyone got it?
Ma'am, molarity is 0.4.
0.2. Don't leave it at 0.2. It is good. It is, your answer is right. but it is after 2, it is 7 and then 8. So 0.2 then will not be considered as the right answer. If you must round it off. If you are writing 0.2, that means you should round it off, right? Have you learned significant figures at some time?
Yes, ma'am.
So remember those. Okay, so it is 450 ml, so is equal to 0.450 divided by 1000, so 450. So that comes to about 0.278. And the unit will, you can write gram per mole or you can write it as capital M. 0.7278, you can write it as 0.278 M, capital M, or you can say it is 0.278 moles per liter, or you can write it as 0.278 moles per liter or moles per decimeter cube. Now, any quantity here, any one of the quantity here will be unknown, right? Any one of the quantity here will be unknown. We can have many types of numericals here. Many types of numericals can come here. Like for example, your question could be that, you know, you need to, the teacher needs to prepare um, 2.5 liters of 2 molar solution of H2SO4. Okay, so a teacher wants to prepare 2.5 liters of 2 molars. Instead of H2SO4, let me take, because H2SO4 we should never prepare like this. So make 2 liters of NaOH, let me make, right? So what weight of NaOH, what is the mass of NaOH will she use? What mass of NaOH is required? Okay, now please think and tell me quickly, any one of you. So if I want to prepare 2.5 liters of 2 molar solution of NaOH, what is the mass of NaOH that is required? Okay, so what is it that I know? I know molarity. Molarity is 2m. Okay, and I know the volume. What is the volume? Volume is 2.5 liters. What is it that I don't know? I don't know the mass of NaOH, right? So how can I do it?
Ma'am, we can find the number of moles of NaOH,
yes,
and molar mass of NaOH and find the mass.
Yes, so quickly do it now. So 2 molar is equal to X number of moles, and volume is already given in liters, so I will write 2.5. So X is equal to how much? 5 moles. X is equal to what? 2.5 into 2, that is 5 moles. And 1 mole is how much? Molar mass of NaOH, you just calculated. Molar mass of NaOH is how much? 40. So what is the mass of NaOH?
Is it 200?
Yes, mass of NaOH will be equal to molarity, moles into molar mass. So number of moles into molar mass. So that is 5 into 40. So that is 200 grams. Okay, this is 40 gram per mole, right? Always when you are multiplying, you must get right with units so that you will get the correct answer in correct units. Did you understand? So some part of it will be unknown. Supposing I need, Sometimes the volume will not be given to you. So if the volume is not given, you should be able to find the volume. Okay. Now the next unit, these are also solutions. Questions we'll do later. Now, another way of expressing concentration, it is known as molality. Now, before I go here, there are two very important things that I should mention here. One is that this molarity, molarity is temperature dependent. Molarity is temperature dependent. Okay, molarity is always dependent on temperature. Why is it dependent on temperature? Can you explain? Sanjay, why should molarity be dependent on temperature? Think about it. Hariharan, why should molarity be dependent on temperature? See what is in the denominator there, the volume of the solution. And volume always changes with temperature, isn't it? If I increase the temperature, what will happen? The volume will also change. And if the volume changes, then what will happen? The molarity will also change. So molarity is temperature dependent. If I say a molarity of a solution, it is only at that particular temperature. If I change the temperature, then the molarity of that solution will change because the volume of the solution will change. Okay, so that is why many times instead of taking molarity, we use another unit for another way of expressing concentration, that is molality. Molality is same as molarity, except what? Except we are taking here the number of moles of solute. But this time we will take the volume of solution. Instead of taking the volume of the solution, we take mass of solvent. This is the only place where instead of solution, we use mass. Mass of solvent in kilograms. Number of moles of solute divided by the mass of solvent in kilograms. Okay. So here, if I simplify it and using the same terms as the mass of solvent and mass of what has happened? I can't even see whether my, just a minute. So my camera is not working, but I can see you all. For some reason, my camera is gone. Okay, never mind. Every day you switch off the camera. Today I have switched off. Okay, so number of moles of solute is equal to the mass of solvent by moles of solute divided by mass of solvent in kilograms. So this one also I can simplify and write W1 into 1000 divided by M1 into W2. Where what is W2? W2 is the mass of the solvent. Mass of the solvent in grams, and to convert it into grams, kilograms, I divided by 1000. So this is a simplified form of the formula. I call it equation number 2. If you can't remember equation number 2, no problem. You should remember moles of solute by mass of solvent. So then you can simplify it yourself. And here again, the very important aspect here is it is temperature independent. Temperature independent. It is independent of temperature. Independent.
Ma'am, but molarity is temperature, no, ma'am. Temperature dependent, right?
Yeah, molarity is dependent on temperature, but molality is independent of temperature. Why? Because mass of the solvent is not affected by the temperature. The volume of the solution can be changed by temperature, but mass of the solvent does not change with temperature. right? So that is why we use in most of our calculations that you will use in this chapter, we will do the calculations in terms of molality instead of molarity. So that is why it is important to introduce this term here, okay? Now I will do a simple question first and then we will do the one which is given here. Let me see if another question is what I have written. Okay. I will use take a simpler question. Now, how do you express? I will first write the unit and then we will take up the question. How will you express the units of molality? Units of molality are moles per kilogram. Moles per kilogram. And what is the way to express? Molarity is capital M. Molality is expressed as small m. Okay, the way to express molality is using small m. Okay, now let us do one simple question. Okay, now the question is you have to calculate molality. Calculate molality of 2.5 grams of ethanoic acid. Ethanoic acid. In 75 grams of benzene. Okay, calculate the molarity of 2.5 grams of ethanoic acid in 75 grams of benzene. The molar mass of ethanoic acid is 60 grams per mole. Okay, now find out. Quickly do it. Anyone? These are easy parts of
0.4 not 2.
No. 2.5 grams of ethanoic acid. So what is the number of moles?
0.041.
0.04 is the answer? No, 0.04 is the moles, right? So this divided by 60, this is gram and this is gram per mole. So that is equal to 0.04.
1/6.
Yeah, gram
1/6.
moles. Yes, it is 0.556. Correct. So molality, the mass of benzene in kilogram is how much? 7.5 divided by 1000. So it is 0.075 kilograms. So what is it? It is molality is equal to 0.0417 divided by 0.075. So that comes to 0.556 moles per kilogram. So this is in moles and this is in kilograms. So it is moles per kilogram. All right. Please take care of the unit. Unit is very, very important. Okay. Now the last question of today. This question is, you have 20% mass by mass of Ki. 20% mass by mass of potassium iodide. You have to find the molarity, and mole fraction of Ki. Okay. Then what is given here is density of the solution is equal to 1.202 gram per ml. Now do it quickly. We are still doing what you have done in class 11. I have not started anything new. So you should be thorough in this. We are just revising. So 20% mass by mass means what? Mass of Ki, right, is equal to 20 grams, right? And mass of solution is equal to 100 grams. So mass of water is equal to 80 grams. This much information I have given you. Now, what is how does the density help me? I can, from the mass of from the density, I can find the volume of the solution. Density is 1.2 gram per ml. So density is equal to what? Density is equal to mass divided by volume, right? Or you can say volume is equal to mass by density, right? So mass is given here 100 grams. Density is given here 1.202. So you can find the volume. And I can also tell you molar mass. Molar mass of Ki. That is 137 plus 137 plus 127. So it is 166 gram per mole. Sanjay? Are you there, Sanjay? Sanjay has disappeared. Sanjay is not there. Now, Sanjay had asked me about the assignment number 3. So, your admin has replied. It is for the yesterday's class. The assignment is page number of your study material. There is a study material given to you. So the page number in that study material is 131 and 132. Your assignment is page number 131 and 132. That is your assignment for yesterday. Okay, children, tell me, did you get anything? Now, Hariharan, you are not doing anything, so that means you have found the answers. Tell me. What is the answer? First, you have to, very importantly, you have to find the moles of Ki. Right? What is the moles of Ki? 20 divided by 166. That is how much? It is 0.12 moles. Right? Now, what is the, so you can easily find the molality. So for molality, you want to know the mass of water in kilograms. What is that? 80 divided by 1000. So that is 0.08 kilograms. Okay. So molality, which is equal to M is equal to
1.5.
Yeah. Divided by 0.08, that is equal to 1.5 molar. Now, what is molarity? Molarity is equal to, that is capital M is equal to 0.12 divided by volume of solution. Now, volume of solution is what? 100 divided by 100 divided by 1.2. That is 83.3. 83.3. So this here, what will be right? 83.3. And so we have to find first volume in liters. So that is 83.3 divided by 1000. So that will be 0.083. So what will that be?
No,
1.44. Yeah, 1.44 M. Okay. Then the next one was mole fraction. Mole fraction is 0.12 divided by 0.12 plus what is the number of moles of water will be equal to 80 divided by 18. So that is equal to what? 80 divided by 18. So it comes to 4.44. So 0.12 divided by 0.12 plus 4.44.
Ma'am, 0.02.
0.02. This will be 0.12 plus 4.44. 4.56. So it is 0.02. Very good, Vaishnavi. 26. Okay, so mole fraction of Ki is 0.6. Did you understand, all of you, the question?
Yes, ma'am.
So now you can calculate molarity, and also mole fraction. Is that clear to you?
Yes, ma'am.
Only
Yes, ma'am.
Vaishnavi is answering. Hari Raghav, did you understand?
Yes, ma'am.
Hari Haran, what about you? Hari Haran, I can't hear you. You can't hear me. Hari Haran Ganeshan. Is he Madhavan? Now you are attending the class from the beginning. Are you able to understand?
Yes, ma'am.
Yes. Hari Haran, are you able to understand everything? Hari Haran is not replying.
Understood, ma'am.
Understood?
Yes, ma'am.
Okay. Now I'll give you 5 minutes to ask me any doubts that you have. Hari Haran, can you hear me? Hari Haran?
Yes, ma'am.
So, are you able to do everything? Have you understood the questions, Hari Haran?
Yes, ma'am.
Okay. Okay. Now from the yesterday's class, I told you if you have any doubts, you can ask me today. Did you read haloalkanes and haloarenes? Do you have any doubts there? Any one of you? Hello? No answer. No answer means no doubt, right? Yeah.
I'm one doubt, ma'am.
Tell
Can
me.
you just show me the conversion?
Which conversion you want?
Bromomethane to propanone.
That one I told, I can show you. Bromomethane, that is CH3Br, 2-propanone, CH3, double bond O, CH3. All right. Now this conversion is a very specific conversion. I can show you how to do it. First, you can add magnesium. When you add magnesium, it becomes CH3MgBr. Right? Now using Grignard's reagent. Now CH3MgBr has a particular way of reaction. Now I particularly didn't take up this, but I will explain to you. You will understand. So we reacted with acetaldehyde. So Grignard reagent adds on to acetaldehyde. You will get a product like this CH3, CH3 and OMgBr. Then you add water. It becomes CH3, CH3H and OH. This is 2-propanol. And from 2-propanol, if I do oxidation, then I will get propanol. Now, reactions of Grignard reagent, you have to still study. When you do alcohols, I told you, you will understand this conversion only when you do alcohol. So deliberately, I left it out for the time being. You will not know how to do because you don't know how Grignard reagent, you have learned how to make Grignard reagent, but you have not learned the reactions of Grignard reagent, which help in how Grignard reagent helps in making propanol. Otherwise, you could have done it. Right? Did you understand? Any other doubt?
No, ma'am.
Ma'am?
Oh, yes.
Ma'am, in that assignment 2, ma'am. Ma'am, can you explain that first question, ma'am? Identify A, B, C, D, E, R. In that second one.
I will just look at the assignment and explain. Just 1 minute.
Yes, ma'am.
Assignment number 2. Yeah. Yeah. In the first question, you are looking, okay. So the first question is, okay, the first question is, you have this cyclohexane ring plus Br, and you are adding to it magnesium in presence of dry ether, right? So Hari Raghav had answered this question quite well. So this, you can help me, Hari Raghav, here. What do you get? First, you get a Grignard reagent. This compound XMgBr. This is what A is. Now, Grignard reagent, when it reacts with water is what? HOH. This is H plus, this is OH minus. In case of this one here, magnesium is positive, and so this carbon here is negative. So negative goes to positive and positive goes to negative. So here H will come. H plus, here H will come. So you will get this cyclohexane plus Mg, Br and OH. Okay. So whatever is your alkyl halide, supposing I take a simpler compound, CH3Br plus magnesium, what will I first get? CH3MgBr. When CH3MgBr reacts with water, then always this alkyl group changes into an alkane. So you will get CH4 plus MgBr and OH. All right. So the R, this part of the alkyl halide makes a alkane. Just add H here, and that is the alkane. Okay. Now we will take another the continuing that question. So here we have RBr instead of CH3, RBr plus Mg in presence of ether, right? So what will you get? RMgBr, right? And now when I add, instead of water, I add D2O. Then H2O, H comes to R. So D2O, D will come. So I will get RD plus MgBrOD, because D2O is DOD. D means deuterium, right? It is a isotope of hydrogen. So it is deuterium. So they are just trying to confuse you. Instead of HOH, which is hydrogen, they have used deuterium. So if it was HOH, it would have become what? RH plus MgBrOH. So instead of HOH, they have taken DOD. Vaishnavi, are you understanding?
Yes, ma'am. Yes, ma'am.
Now you got it? Now yes, the next one is CH3 and
CH. In that they have asked us to identify R.
Okay, let us see what it is. This one, right? And sodium, or this way. Which two will combine in presence of sodium and dry ether? Okay, dry ether. So this one, it should be cut here because that has got doubled. So what should be the alkyl halide? Your alkyl halide are in the, so it will be CH3, C, CH3, CH3 and X, isn't it? And X. All right. So what is R? Yes, this is R. So when I write Grignard reagent, I add Grignard reagent Mg. What will it become? It will become CH3C, CH3, CH3 and MgX. And when I add water, what will it become? It will become this, and here you will get what? H.
Yes, ma'am.
You will get the alkane.
For this I got, ma'am. For the before reaction, RBR, for that, what will be the R?
RBR, no, that here it is, this is R, this one is, they are saying RBR, which is R. What is the R here? This is this part which I've indicated here. This is the R. This one is the R.
Ma'am, so this is a full continuous question, ma'am.
Yes, full continuous question.
Oh, okay.
Okay, you can see arrows on the left, and first it is arrow on the left, then it is arrow on the right. So Rx is giving this, the Rx is giving this, and the Rx is, you have to, is also giving this. So what is RBR? This is RBR, this one. Do you understand
Okay,
now, Vaishnavi?
Yes, ma'am.
Okay. Okay, then see you all next week. Thank you very much.
Oh,
Thank you, ma'am.
Ma'am.
Thank you, ma'am.
Bye. Bye. See you.